Hello everyone, welcome to STEM Aerocobi Academic Channel. I'm Haftom Aragawi, lecturer in Electrical and Computer Engineering. In previous lecture, we have seen a roadmap of C++ programming language course for beginners, intermediate, and advanced learners, right? In today's lecture, we mainly focus on the history and evolution of C++ programming language, giving learners context for why C++ works the way it does today, right? But before we proceed to the origin and features of C++ programming language, it's better to answer why history matters for C++ learners or any other programming language learners, right? Why history matters for C++ learners? Knowing history for the learners helps to understand language design. When you know that C++ evolved from the C language, you understand why C++ feels like two languages in one, right? For example, C++ programming language, it gives low-level control like C programming language, pointers, memory management, direct hardware interaction, right? It also offers high-level features like classes, templates, smart pointers, and lambdas, right? History explains this dual nature. C++ was designed to be powerful for the system programming and comfortable for large applications at the same time, right? Knowing the history for the C++ learners helps to better handling of legacy code. Many companies still use older version of C++, especially in banking system developing, in telecom, in developing different embedded systems, and in developing different operating system components, right? Therefore, knowing the history helps you understand why older code looks different and how to maintain or upgrade it, right? You will be able to read C++ 98 or C++ 003 code confidently because you know how the language used to work, right? Knowing the history for the C++ learners helps to appreciate modern C++, like C++ 11, C++ 14, C++ 17, and C++ 20, right? Modern C++ features were created to solve long-standing problems. For example, smart pointers, which helps to solve memory leaks, auto keywords, which can simplify complex type declarations, lambdas, which make code shorter and cleaner, concurrency for better multi-threading, modules, which helps to fix header file issues, right? When you understand what programmers struggled with before, you appreciate why those modern tools exist, and you learn them faster, right? Knowing history for the C++ learners helps to career and interview advantage, right? Understanding the evolution of C++ shows you are serious about the language, aware of industry practices, capable of working on both new and old systems, knowledgeable in system-level programming, right? Therefore, interviewers often ask about the difference between standards like C++ 98 versus C++ 11. And knowing the history helps you answer confidently, right? In short, understanding the history helps you appreciate design decisions, strengths, and modern best practices, right? However, learning history is not just an academic, right? But it helps in debugging legacy code, understanding standards, and predicting future language trends, right? Let's see the origin and features of C++ programming language. C++ was created in 1979 by Bjarne Stroustrup at Bell Laboratories, right? At that time, programmers were using the C programming language because it was fast and efficient. However, C programming language lacked higher-level tools needed to build large and complex software systems. Stroustrup wanted to combine the speed of C programming language with the modern programming features that could make coding easier, faster, and more organized. Therefore, Stroustrup's main motivation was to improve productivity while keeping performance high. He wanted a language that ran as fast as C, but allows programmers to manage large projects more easily, and supports concepts like data handling, data hiding, reusability, and modularity, right? This led to the creation of a new language, right? The C++ original name was C with class. Before it was called C++, the language was named C with classes. Why? Because early versions were literally C code plus classes, right? The main feature used in object-oriented programming, right? The key features added early in C++ programming languages are classes and objects. This allowed programmers to bundle data and the functions that operate on that data into one unit. This is known as encapsulation, right? Constructors and destructors. Constructors automatically set up an object when it is created, right? While destructors clean up resources when the object is no longer needed. This reduced errors and made memory management easier, right? Function overloading. Programmers could use the same function name with different parameters, right? This made code easier to read and more flexible. The fourth one is strong typing. C++ became stricter about the data type, helping catch errors early, right? Let me give you simple examples. Imagine you are building a student management system, right? Using C programming language and C++ programming language. When we use C programming language to build a student management system, you would use structures to store student data. You would write separate functions to enroll, grade, or display students. Nothing ties the data and function together, right? You must manage everything manually when you use the C programming language to build a student management system. However, when we design the student management system with C++ programming language or C with classes, you create a student classes that contains student data and functions like enroll, add grade, and display information. Each student becomes an object of this class. The system becomes cleaner, which is data and operations are grouped, safer, is less chance for error, and reusable. The student class can be used in many programs, right? So let's see the evolution timeline of C++ programming language, right? C++ has grown a lot since its creation. Over the decades, the language has been updated many times to make programming easier, faster, and more powerful, while still keeping the speed of C programming language, right? In 1983, C++ gets its name, which is the name of C++ was officially adopted, right? The ++ represents the increment operators in C, meaning an improved version of C programming language. This name symbolizes that C++ builds on the top of C programming language, right? In 1955, first C++ book was published by Bjarne Stroustrup, which introduced programmers to the ideas of classes, objects, and object-oriented programming in C++ programming language, right? In 1989, software companies began releasing official C++ compilers, right? Allowing developers to write and build real C++ applications. This marked the point where C++ became widely usable in industry. In 1990s, different companies and developers were using different versions of C++ to bring everyone together the International Organization for Standardization, which is ISO, began working on a unified standard, right? In 1998, C++ 9.8 becomes the first international standard, right? It defines the core language and the standard template library, including vectors, lists, maps, and algorithms. After C++ 98, C++03 in 2003, a small update to fix problems and clarify the C++ 98 standard. No major features, mainly polished, right? In 2011, C++ 11 is considered the biggest update in the history of the language. It added modern features like auto keyword, mil pointer, smart pointers, lambda functions, move semantics, multi-threading support, and range-based for loops. This release made C++ more expressive, safer, and easier to write, right? In 2014, a minor but helpful update with generic lambdas, variable templates, small performance and usability improvements. In 2017, expanded the power of the language, structure bindings, complex time decisions, file system library, improved templates, parallel algorithms, right? In 2020, another major upgrade, C++ 20 brought several powerful modern features like concepts for cleaner templates, ranges library, asynchronous programming, modules or alternative to header files, calendars or date library. This version greatly improved code readability and compile time safety, right? In 2023, focused on improving the standard libraries, making the language more consistent, adding quality of life features of developer, right? From the evolution we have understand, every new standard makes C++ more modern, safe, and powerful. But C++ still keeps backward compatibility, right? Meaning old programs can still run with new compilers. This is why old C++ code looks very different from modern C++ code. Old style, which is manual memory, old looks, raw pointers, right? Modern style, smart pointers, lambdas, auto, and ranges, right? Let's see the key features added over time. In early 1980s, the C++ programming language has a feature class and object-oriented programming. Its purpose for encapsulation, for abstraction and reuse, right? In 1990s, the feature of C++ includes templates, right? Its main purpose is for generic programming and type safety, right? In 1994, the feature of C++ programming language was standard template library, and its purpose for ready-to-use containers and algorithms, right? In C++ 11, it has almost those features, right? Smart pointers, which is for automatic memory management, lambda functions for concise functional style codes, concurrency for multi-threading support, right? In 2020s, is concepts and ranges for expressive templates, modern functional programming, right? In short, C++ programming language evolved from C programming language, which is a low-level efficiency, to modern C++, which includes high-level abstraction, safety, and performance, right? Each standard addresses new needs like concurrency, generic programming, and functional style features, right? Understanding history helps you read legacy code, use modern C++ effectively, make design decision for performance critical projects. So the motivation for learners, by knowing why feature exists, you write better, safer, and more maintainable C++ code. See you.